Hi, welcome to STEAM Kids Virtual Classroom at the Colorado Model Railroad Museum. I'm Museum Director Michelle Kempema, and I'm here with Peter Romero.
Science geek extraordinaire.
Yeah, we increased your title last time.
Thank you. Thank you so much. So today we're going to talk about, so today's the day, or tomorrow's the day.
Tomorrow's the day. Perseverance lands tomorrow.
Yeah. But I thought first we'd talk about something that may seem a little bit unrelated, but it's very important. Boiling water. So, when you were in school, you learned about the boiling point of water, right?
Yes.
What was the boiling point of water?
212.
212 degrees Fahrenheit, or 100 Celsius. But you know what? That's not always the case.
Really?
Yeah.
So that just isn't the same all over the planet?
It's not the same all over the planet. It's not the same all over the universe. So I've got some boiling water here. So why don't we measure it?
Okay.
So I'm just going to take this thermometer. This is a kitchen thermometer. If you try this at home, have an adult with you, and do not use your bathroom thermometer for when you get sick. It'll break.
Yeah.
Use a kitchen thermometer. So I'm going to measure the boiling point of this water. This is like a full rolling boil. And it ought to be 212. But it's only 204.1 degrees.
So why would that be?
It's lower.
It's lower. So it boils at a lower temperature.
Mm-hmm.
Now, why would that happen?
Well, where are we?
Well, we live in Colorado. We're here in Greeley, Colorado, and our elevation is almost a mile high.
Yeah, we're about 4,600 feet high. And so...
From sea level.
From sea level.
We should say how high we are from where the ocean hits the shore of the continent.
So at sea level, the air pressure is about 1,000 millibars, and at 1,000 millibars, the boiling point of water is 212 degrees.
So you have to be at sea level to hit the exact 212.
Yeah, but up here we have about 15% less air pressure. So the water boils lower because the molecules of the water, they're kind of rolling around in there in the liquid, and then sometimes you get one that has more energy than the rest of them, and it just shoots out. And if you've got a lot of air molecules, it might bounce off of one and go back into the liquid, so the air kind of keeps it in there. But if you have less air, it's less likely to do that, and so the boiling point can go down.
So the boiling point is lower.
Yeah. If we were on top of Mount Everest, the boiling point of water would be down at 154 degrees.
Wow. So water would boil a lot sooner when you heat it.
It'd be a lot easier to boil it.
Yeah.
And the reason this is important is because on Mars, the boiling point of water is 33 degrees Fahrenheit.
Wow. That's 1 degree
cold.
above freezing for us.
And so the freezing point of water doesn't really change based on air pressure.
Because it's 32 degrees.
It's 32, so you've only got 1 degree where it's liquid. So you've got ice, liquid water for 1 degree, and then steam.
So it'd be really hard to maintain water on the surface of Mars.
So if we want to eventually terraform Mars, make it more like Earth, one of the problems we'd have to solve is getting a thicker atmosphere, because otherwise we won't be able to have liquid water.
Liquid water. And this is what Perseverance is doing, is studying ancient water on Mars. Can humans live on Mars?
Right.
Answering those kind of questions. How are we going to do this? But very interesting.
A lot of challenges.
Yeah.
So, right,
tomorrow. Turn off your boiling water.
I'm going to turn this off so it'll be less noise for us. But tomorrow's a big day, and there's a lot to do to get ready for the landing. Now, we talked yesterday or last week about escape velocity. So the spacecraft, when it's traveling through space, is going like 25,000 miles an hour.
Right. And is approaching Mars at 25,000 miles.
No, it slows down a little bit. It has some retro rockets. So I think by the time it starts its landing process, it's going about 12,500 miles an hour.
12,500 miles an hour is still very fast to try to land something.
Yeah, I mean, if it hit the planet at that speed, it would just vaporize the thing.
Yeah. So some of the things that they're taking into account to make that happen, I know there's a heat shield, because when it hits that fast into the atmosphere, the heat is so high it would melt Perseverance.
Totally destroy it. The heat will be 2,300 degrees Fahrenheit.
There's an entire shield that's the front of the rocket. Think of it as the cone part, really, is all heat protectant.
And the heat shield is made of a material that, first of all, can absorb a lot of heat, but also a lot of it burns away. So
by the time they get to the point that they're going to hit the next stage, that will have all burned off. And so then what is the next stage?
Well, so it hits the atmosphere, and then the there's a parachute that comes out of the back of the rocket, which is really big because the atmosphere is so thin.
Yeah. And NASA has a picture of that parachute.
Yeah, it's cool.
It is massive, huge, way bigger than any parachute you've ever seen used on Earth.
So that slows it down. That absorbs some of that speed. And then there's also retro rockets on the spacecraft that fire in the opposite direction.
Right. So if this is your spacecraft, they're firing this way to slow you down.
So it's braking.
Yeah.
It's braking. And then in all this whole time, the rover has a camera on the bottom of it, a downward-facing camera that's looking for a place.
It has a pre-program in it that is looking for the right conditions to drop Perseverance.
And remember,
onto the ground.
we have like an 11-minute delay between us and Mars, and so the spacecraft has to do all of this by itself because we don't have enough time to guide it.
Right. It is not live guided. So everything has to be pre-programmed. So it is smart enough to know what it's looking for. As it has those retro rockets going, it can move around. And when it finds the right place, it will drop Perseverance down.
There's a cable.
There's a cable.
So it like lowers it on this cable.
It will lower it down. And then it's going to detach. And because it might fall when it runs out of fuel and land on Perseverance, it will actually, once that's detached, it will fly away to another part of the planet.
And crash.
But that way it's not in the way. And if it landed next to it, the rover couldn't go there. And there's always that risk of it falling on the rover. So,
many
it goes
steps.
way far away.
So many things have to take place to get this to happen.
Yes. So tomorrow we are all going to wait on pins and needles to see what really happens.
Tune in. It's about it's going to be starting at noon Mountain Time. So if you go to the NASA website,
NASA has
YouTube,
links.
Twitter.
Yeah, I found a Facebook group that's live streaming, and you can find it on the internet. Just look for Perseverance.
But be ready to start watching about 12:15. You said 12, right?
The events are starting at 12, but I think the actual live stream will happen at 12:15. It'll probably land at noon in our time, but we won't see it, right?
Yeah, I'm not sure.
The delay.
Right. That could, I don't know.
I don't know. We're going to find out tomorrow. It's really exciting. So we're really happy you've joined us for Mission to Mars. We're going to continue a space theme in our STEAM Kids Virtual Classroom for our next set of lessons.
This has been a lot of fun.
Yeah. So thank you for joining us.